In this module, we're going to have two different videos. This first one is going to be about how to use Excel to estimate demand and talk a little bit about forecasting. In the next video, it will be more about estimating elasticity and converting the data so that our actual estimates are a little more useful in regards to the previous module where we showed all these different ways we can use elasticity. The next video will focus on really, okay, if we want elasticity, how do we estimate it the easiest? But this one's more about getting Excel ready to estimate things, estimating demand, talking about variables, those sorts of issues. For both of the two videos in this module, there will be a link on Blackboard to the data that I use within here. So if you want to download the data and you want to try and replicate what I do in these videos, that's something you can easily do. And if you're not sure you're doing something right, I would encourage you to do that and just verify you're getting the same things that I'm showing in these videos. Okay, so the first set of data on Blackboard, there's two of them. There's one called gasoline price data or gasoline demand data. And this is tab 1 within that data. And it simply has, over time, these are real data from the government. So the first column has year, and then real gas prices, so adjusted for inflation, and then consumption of gasoline. The real gas prices are in cents. So once you get over 100, you're over $1. And consumption of gasoline, I want to say, is in millions of gallons, but it might be hundreds of thousands of gallons. I can't remember what, but it's simply scaled down. But the number is actual consumption of gasoline. So with this, we should be able to estimate a demand equation. As we saw in the last model, we tend to think of, okay, quantity demanded of some good, in this case gasoline, is a function of the price of the good, and then the equation we had last time was the price of other goods, so maybe the price of X, income, all kinds of other taste preferences, those sorts of things. So with the information we have here, quantity is right there, and price is right there. So we should be able to estimate our demand equation with just this information. Now, I'll talk after we estimate the most basic demand equation about why we might want to include other variables, those sorts of things. But with this, we should be able to estimate a demand equation. Okay, so what we're going to do is we're going to look for, and I'll talk in just a second a little bit more about how to make sure if your screen doesn't look like this, how to enable it. But we're going to look for this tab up here called Data. And we're going to click on the Data tab, and we should get something that looks like this. Okay, so this is clicking on the Data tab, and then we're going to go all the way over here to the right, and we're going to look for Data Analysis. Now, if you don't see Data Analysis, there is a document on Blackboard that talks you through or walks you through enabling the data analysis tool pack in Excel. You're going to go File, Options, and then Manage Excel add-ins, and you're going to check for Analysis Toolbox. You can also install Megastat. So on Blackboard, I've got a separate folder with an old version of Megastat and some instructions on how to do that, and that would also work in this case, but you'd have a separate tab for Megastat. And you'd be able to do the same stuff. So it's what works best for you, what you prefer. In this video, I'm just going to focus on sort of the built-in Excel regression analysis stuff, since we don't need a lot of the other fancy bells and whistles that Megastat does. But if you prefer Megastat, you can go that route too. So we're looking for data analysis. We're going to click on data analysis, and when we do that, up is going to come a pop-up that looks like this. Okay, and it's alphabetical, and we're going to be looking for regression. So we're going to click on regression, click OK, and then we're going to get this. Okay, so this is asking, there's lots of options here. the options down here, or, do you want it to graph it out? Do you want it to plot it out? Those sorts of things. Most of this stuff in this class we're not going to have to worry about. If you were going to do this is solely what you do for a living, you'd get used to all those different tools and all that stuff. For this class, we're not going to worry about that. So what we're going to have to do is we're going to have to use input Y range, input X range, and we will talk about this in a second. Okay, so my Y range, so remember what we're estimating is quantity demanded equals a function of price and potentially other stuff, and we'll come back to that. Okay, so this is in the form of Y equals mx plus b, where this is my intercept, m is my slope, x is my independent variable. It's the variable that we know or we observe or we set, and y is what's being caused by x and the slope and the intercept. So given our equation above, our y variable is going to be consumption and our x variable is going to be price. So we're simply going to click in there, and it's going to open up a new box that's going to ask us to select our x variable, or our y variable, and we're going to select for our y variable consumption of gasoline. And the way we're going to do that is we're just going to click on C1 and we're going to drag it down to the end through all the information that we have on consumption. Unfortunately, Excel's a little weird in some regards, so we don't just want to click on the C column, because if it grabs blank cells, it freaks out that, hey, there's no information here. So you literally just want to drag it through all the consumption data. You can either scroll to the bottom and drag up, or start at the top and drag down, but you want to select all the consumption data, because that's quantity as Y. And then you're going to come and you're going to click on the input X range, and you're going to select all of the price data, and that's going to be X. Once you have those in there, you're going to click the labels box. The labels box is simply going to tell Excel that the first row is not data, it's actually the labels or the variable names. If you don't click labels, it's again going to freak out, because it's going to say, hey, that's not data in the first row. But by clicking labels, because you could conceivably just not select the first row, but by selecting the first row and clicking labels, it's going to make our results a lot easier to interpret, because it's going to show us that this estimate applies to this variable. So we want to go ahead and click labels, and we want to go ahead and select the first row. Once we input the X range, the Y range, and click labels, we're going to click OK, and we're going to get our results, which look like this. Okay, now this isn't a stats class. At some point you guys have taken stats classes, potentially many of them, and you go through all kinds of different statistical analysis. Here the assumption is, okay, you've seen that before. You could maybe talk about the goodness of the fit of the model, all those sorts of things, but we're going to really focus in on this information here. Okay, and notice if we didn't click on labels and include the variable names, those would just say like x1, x2, something like that, whereas here they actually tell us the top one's the intercept, the next one is gas prices. So the coefficients tell us, so basically what we've estimated is quantity demanded equals, okay, the coefficient on the intercept, 539.28, rounding a little bit, plus 11.89 times price. Okay, that's what we've estimated. Now, so the coefficients tell us what the equation looks like. The standard error, the t-stat, the p-value tell us whether we have statistical significance. If we don't have statistical significance, then we can't conclude that anything is different than zero, and we don't really have a valid demand curve that we can talk about. So t-stat, you can look up a t-table and determine statistical significance for the number of observations, those sorts of things. For our purposes, most of the data I'm going to give you, you're going to get statistical significance. A rule of thumb for data that has a sufficient amount of observations, a fairly large amount of observations, anything over 2 as a t-stat is generally going to be statistically significant. But you could go through and you could calculate it and that sort of stuff. But for our purposes, we're going to be more, how do we do this and how do we use it? The statistics class that you guys take is really more geared to, okay, is that really significant and stuff? For our purposes, we're going to usually just have it be significant. But a t-stat of 2 or greater in absolute value is going to basically guarantee that we're statistically significant. Okay, now, if you're paying attention here, this part of our estimation should be concerning you because we spent a great deal of time in the last module talking about how demand is downward sloping. How when price goes up, quantity goes down, when price goes down, quantity goes up, and yet our estimate here, this is positive. If that's positive, that means as price goes up, quantity goes up. That's a little bit troubling. That would imply that demand looks like that, and we know we don't want that. We know that doesn't make any intuitive sense, that customers buy more when price gets higher. Okay? Now, in general, if you're getting a demand curve that looks like that, it does not mean demand is upward sloping. The correct answer is never going to be demand is actually upward sloping. The correct answer is going to be, okay, I'm not accounting for everything impacting demand. In this example, we have price and quantity over time. Well, lots of things are changing over time. There's differences in population, differences in income, differences in all kinds of things. There's lots of things changing over time. It's not just that demand is upward sloping. So we need to account for those other things. So in general, if you're getting an upward sloping demand curve, all that's telling you is you don't have enough variables included. So let's talk about adding another variable. Okay, we have in the original data, we had year. Well, let's just plug year in as an x variable so that we have quantity demanded equals, call it like M1 times price plus M2 times year plus B, so that's our intercept. So in this case, quantity demanded equals negative 3.15 price plus 32.77 year plus, or sorry, minus 63,516.3. Okay, so there's our new demand equation. For the intercept, don't worry about the positive, negative. All the intercept's doing is making sure that the line generated here goes through the data as best as possible. So the negative, it's telling you if you had a zero price and you were near zero, well, year zero, that's a long time ago before we were using gas, so it's kind of irrelevant. So don't worry about the intercept. Don't worry that it's negative and big and all those sorts of things. But notice this. This is now negative, which is a downward sloping demand curve. As price goes up, quantity goes down. As price goes down, quantity goes up. Negative 3.15. So for every 1 increase in price, we end up with a negative 3 decrease in quantity. Now, remember our units, price is measured in cents. So for every 1 cent increase in price, we see quantity fall by 3,000 million, whatever those increments were, which we talked about before, gallons of gasoline. This one tells us that over time, demand for gasoline has gone up. Well, that makes sense. There's more people, there's more cars, people drive more now than they did back in the 70s, those sorts of things. But this gives us a demand curve that, okay, that makes some good sense. But we still might not be happy with it. We still might say, well, there's other things that impact this, not just time and price. And so we could add more data to it. So here's the same data with real gas prices and consumption, but here we're going to add income and population along with years. So we've got extra information. So it's not just it's increasing over time, but income's changing over time, population's changing over time, maybe preferences are changing over time, all these things. Now, I put these in specifically when you're doing this in Excel, and this is another quirk of Excel. When you go to select X variables, you can select as many X variables as you like, but for whatever reason, and this is just an Excel thing, they have to be next to each other. So you have to select the X variables as like a big block. You can't like say, okay, I want C and then I want E, but not D. They all have to be together. So that's why I put population and income sort of right here next to prices and year, and kept consumption on the far right. So all you're going to do here is you're going to go through those same steps, data analysis, regression. Your Y variable is still consumption. Your X variable is now going to be all of these other variables. You're going to click labels. You're going to click OK, and you're going to generate this. Okay, so notice here we now have, okay, what's happening over time. So we've got our year. We've got our population. We've got real gas prices, which is still negative, and it's a good thing. It hasn't changed dramatically. Before we were negative 3.1514. Here we're negative 3.33. So it's pretty, you can always tell when you're getting close to the right model and all the things in when things are not changing dramatically as you add new variables. And income is 0.03. Notice here for population, that's not going to be statistically significant because it's very, very small. Everything else looks like it's going to be statistically significant. So gasoline demand is increasing over time. It is decreasing as price goes up, and it is increasing as people's income goes up. So we're just looking at the positive versus negative. And you could sort of think of every year we have 17 units more, and again, those are thousands or millions of gallons of gasoline demanded. For every 1 cent increase in price, we see a drop of 3.33 units of gasoline, and as income goes up, a 1 unit increase in income, which is $1 basically since it's per capita income, increases gasoline consumption by 0.03. So as income goes up over time, that starts becoming a fairly large thing, and it is statistically significant. So this video is really aimed at, okay, how do we estimate demand, including other variables, those sorts of things, interpreting it. The next one's going to be more focused on, okay, now that we know how to estimate demand, how do we estimate elasticity directly?